everyone. Let's take a look now at the derivatives of the inverse secant and inverse cosecant function. Now, in my previous two videos of this series, I went through the inverse sine and cosine, the inverse tangent and cotangent, and now I'm going to go through these two. The derivation of this is very similar to the previous types. So let's take a look here at the derivation of y equals the inverse secant of x. Now again, we don't know the inverse secant derivative, so that's what we're trying to find. But what we do know is the derivative of secant. So what I'm going to do is I'm going to take the secant of both sides. That gives me the secant of y equals x. Because again, if I take the secant of this side, they cancel each other out and I'm left with x. So now I take the derivative. And remember, the derivative of secant is secant y tangent y. And of course, we then do dy dx. And that equals 1. All right, pretty straightforward so far. Now, of course, we have to get dy dx by itself. Just like in all the previous videos, we've had to do this type of solving. And so we get secant y tangent y. Well, again here, notice we have secant y and tangent y. Okay? We already know what secant y is. Secant y is going to be x, but we don't know what tangent y is. But we can use, again, the Pythagorean identity. We used this one yesterday. Okay, remember 1 plus tan squared x equals secant squared x. We used that in my previous video. Write that a little bit better. Secant squared x. Okay? So what we have to do here, since we don't know what tangent is, we need to solve this guy for tangent. In fact, let me put y's here to kind of match up the problem. We'll do those as y's. So we get tan squared y equals secant squared y minus 1. Then, of course, we would take the square root of both sides, and that would give us tan y equals plus or minus the square root of secant squared y minus 1. All right, and we do have to do plus or minus because the domains of tangent would yield a negative and a positive here for the secant. So these are things we have to consider. So when we do our substitution, though, there's a way to handle this guy, okay? And I'm going to show you now. So what we do our substitutions, and we say dy dx is equal to 1 over. Now here's how we handle the plus minus, and this will help us out. We actually put an absolute value around the x that gets substituted for the secant y. And then we write out, notice this is secant squared y minus 1. Well, secant squared y is x. So this becomes x squared y minus 1. And here is your derivative. Okay? Now, of course, the inverse secant is derived exactly the same way, except we're using 1 plus cotan y squared y equals cosecant squared y, and the derivative would be negative. So if we took the derivative of this, we would get negative 1 over the absolute value of x times the square root of secant, of x squared minus 1. Okay, and those are our derivatives. So let me kind of summarize that for us here again. If you have y equals the inverse secant of u, then your derivative would be u prime over the absolute value of u times the square root of u squared minus 1. And the derivative of of cosecant, let me rewrite that out. If you had y equals cosecant, the inverse cosecant of u, then its derivative would be u prime over, and that's negative u prime over the absolute value of u times the square root of u squared minus 1. Okay? So not bad there. These are not hard derivatives to do. So what I want to do now is take a look at a couple of examples. So I'm going to clear all this out and let's take a look. Let's take a look at, y equals secant, the inverse secant of 3x to the fourth, And let's take a look at y equals the inverse cosecant of 2x minus 4. All right, so if we follow the pattern of u prime, etc., again, let me put these up here. U prime over the absolute value of the square root of, and we have that. And this one would be negative u prime over absolute value of u times u squared minus 1, the square root of u squared minus 1. All right. Now remember, the guy in parentheses is our u. So in this case, dy dx is equal to this guy, the derivative of this, which is 12x cubed over the absolute value of 3x to the fourth, and then the square root of that minus 1. Now, of course, an answer key might have this a little bit more simplified as this, at least squaring out the piece underneath the radical. So this might be as 9x to the 8th minus 1. So just be mindful of that. Pardon me. Now with this one, if we took the derivative, dy dx would equal negative, because of the negation, and then the derivative of this piece, so that's 2, over the absolute value of 2x minus 4 times the square root of 2x minus 4 squared minus 1. And there is your derivative. Okay? So I'm going to clear these out now. Again, if you want to write them down, pause and write them down. But I'm going to clear them out, and we are going to now look at a couple of more advanced ones. So let's take a look at y equals the inverse secant of ln x. Ooh, a natural log. How nice, huh? And y equals x cubed times the inverse cosecant of 3x plus 4. Okay? So that's what we're going to work with now. So let's take a look at this derivative. Again, we're going to follow the same pattern of u prime, etc. Okay, so dy dx is equal to u prime, so the derivative of this, which is 1 over x, times the absolute value of ln x, and then the square root of ln x squared minus 1. Now, this can be simplified to where you take this kind of triple level fraction, you take the x that's up here and drop it into the denominator where it belongs. Okay, and it might look like something like this. Okay, so be mindful that that can happen when you simplify things. Now the second one here I'm going to do is a product rule question. So I say dy dx is equal to, well, this is the first part, so I'm going to take the derivative of this guy first. So that's 3x squared times the second part, which is this, so the inverse cosecant of 3x plus 4. And then I would normally do plus the derivative of the inverse cosecant, so that would be minus the 3x plus 4 over the absolute value of 3x plus 4 times the square root of then 3x plus 4 squared minus 1 times this first part, x cubed. Okay? Now you might see this written slightly differently if you were going to do any little bit of simplification with it. Like so. You might see the x cubed in the numerator up here with the 3x plus 4. It might even be distributed there in a more simplified form of this. So keep that in mind. Again, you don't really have to distribute or expand out the squared piece onto the radical. That you usually don't see that done. So, okay, so this is the last of the series of the inverse trig videos. Though I might add another one with just a few more examples at a later date if necessary. Hopefully this helps you. Have a great day.